Hello kids. Today we will be reviewing the second unit, which is describing motion for IGCSE physics with course code 0625. The unit is mainly regarding speed and velocity of an object. We will then review the changes in speed and velocity, which is known as acceleration. So let's get into this. So let's define what is speed, right? So what is speed? Uh, Speed is actually uh, okay. What is speed? So previously we discussed length, right? And we said length can be called with several names, namely uh, distance, right, between 2 points is also length. Let's say from point A to point B, that is also length. Then we also use another unique term for distance, which is displacement, right? Now first, before we get into speed and velocity, I will differentiate between the two, what is distance and what is displacement. Let's say I've got this point x and this point y, right? Now a car may have to take some alternate paths to get to point y. So the odometer, of the car will give you a certain reading. Let's say what is an odometer? It's the it's the digits that it gives for a trip. Let's say it gives you the trip. Let's say 560 meters, right? So it traveled from point X to point Y, and the odometer was set to 0 at point X, and till point Y it took a road that which was a bit curved, so it read 560 meters, right? So and during this course, as you can see, the direction of the vehicle, let me draw several direction vectors. At this point the car was facing this side. At this point the car was pointing at this side. Over here it pointed this way, and finally it was going towards this side, and at point Y it pointed this way, right? So the direction is consistently changing, but this odometer does not care about that. It only measures it with the revolutions of the tire and how much tires have traveled, or the car has traveled along the road. So this is what we call as distance, right? So distance is the amount of length covered in a specific path, right? So we can say length of a path, right? That is what a distance is, uh, uh, irrespective of direction, right? So the direction doesn't really count when we're discussing distance, right? But if I want to know how far, or what is the change in position, now this does not specify position. What is position? Let's say if I draw a graph, right? I put x at origin O, and I simply draw a vector or a straight line from x to y, right? Let's say this is y point over here. So uh, this straight line length would be displacement, right? So what is now displacement? It represents the shortest straight line length between 2 points. Also it refers to position change, right? So displacement we consider as a change in position from point X to point Y. We don't care about the path. We just identify what is the shortest possible length, or a straight line length between these 2 points, and that is what we call as displacement, right? So this is a brief of what these two are. So this is actually a vector quantity, right? And this is what we call as a scalar, right? Now we're supposed to be discussing vectors and scalars in the subsequent units of force, where vectors and scalars is considered as a last topic in IGCSE, but I would like to give you a little bit hint of vectors and scalars in this unit. that vector are those quantities which are direction dependent, right? For them, direction really matters, right? So direction counts for scalars. Direction doesn't matter, it's just the quantity, right? So it is direction, quantity, uh, plus direction. That those quantities are known as vector quantities, and quantities which only signify the magnitude are called scalar, right? Scalars. So now let's get into our real topic of speed, right? So let's say you have a car that starts from point A, gets to point B. Now I'm just going to draw a linear line, right? Now you had discussed types of motion in your early science books in grade 7 and grade 8, but I will also signify as a miscellaneous topic of the types of motion in a while. But for now, let's say it's a linear motion. A car is going in a straight path on a straight road. So it starts from point A. The total length of this path is, let's say, 100 meters, right? And on a stopwatch, the car, we start the stopwatch at point A, and as soon as it reaches point B, we stop the stopwatch, and the stopwatch reads the time, which is small t, to be 20 seconds, right? So the car took 20 seconds to cover a distance of 100 meters. So what is speed? Speed is what we define as distance covered over time taken uh, to cover that distance. So that would be for it is represented by the symbol small v. So it would be d by t. That is going to be this is over here d, right? So it would be 100 meters divided by 20 seconds, right? So this would sum up to be somewhere like this, 5. So it gives 5 meters per second, right? So that's the speed of the vehicle at which it covered this distance. Now over here I would signify that we are not talking about the changes in speed. The speed of the vehicle was consistent. So if we consider a constant speed, let's say a car was already moving at this speed, we just tagged it at point A and saw how much it went over a distance of 100 meter till it reached point B. So constant speed would be represented as is, but not always that we get a constant speed. We also get variable speed, so we will discuss variable speed in a moment, but for now let's consider we're just discussing constant speed, right? So if I try and understand this, I plot this as a graph, right? Let's say we have uh, distance, which is in meters, and we have time, which is in seconds. So we do know it covered, let's say point A was referred to as origin. So for every, let's say I divide, this is 100 meters, I divide it into 20 meter brackets, right? I think that's it. It would be 20, it would be 40, 60, 80 and 100, right? 100 meters, and I divide the time similarly in similar intervals, right? I divide it in portions of 4 seconds, right? 4, 8, it's going to be 12. Don't mind the small number, let me just make it a bit more bigger so that you understand. Let me just wipe this out. Okay, it's 12, then it is 16, and finally we get 20, right? This is, we're talking about t in seconds, which is in this way, and this is distance over here on the y-axis. So once I draw this, so my line is going to be, let's draw this point. Now I'm going to draw a chart as well, where I'm going to plot distance, where it is, sorry, yeah, there you go. We have distance and we have time, right? So let's chart it out a little bit. So we get 20, we get 40, then we have 60, and then we have 100. Sorry, 80 and 100. My bad. Okay. Yeah. 80, and then we have 100, right? And for this, the times were also lapsed at, let's say, 4, 8, 12, 16, and 20. So consider this as the y-axis, right, and this as the x-axis of the chart, right? So the first point would be over here at 4 and 20. The second point will be at 40 and 8. Third point will be at 12 and 60. Next would be at 16 and 80, and last would be at 20 and 100, right? So I simply join these values and I get a straight line. Now this straight line represents constant speed. Why? Because the gradient, or what is gradient? Now let me just define. The gradient is y over x, right? Or you can say the change in y, delta y over delta x, right? So any change in y, let's say between 2 points of let's say, let me just draw this, between 80, 60, and between 8 and 40. So let's do this. What's the gradient? That is going to be between 16 minus we have distance on top, right? Y-axis first. Okay, we've got 80 minus 40 divided by 16 minus 8. So it turns out to be 40 divided by 8, which in turns 8 ones are and 8 8s are, right? So it is actually 8, right? Then this is the gradient, right? 8 over here, and since we have distance, it is actually 8 meter per second, right? So the gradient can also be referred to as the steepness of this graph, right? So if we plot these graphs like this, right? So this is actually the total of what we're supposed to be working, but this is what the gradient is at any point. We can do this now. Let's take another point, right, between 60 and 20, right? Okay, let's do 60 and 20 now. It is going to be again, gradient is delta y over delta x, right? So the gradient is 60 minus 20, right? The difference of between the higher value and the lower value, and between time, it is going to be 12 minus 4, that is again going to be 40 divided by 8, resulting in 8 meter per second. So the gradient remains same. Since the gradient is not changing, so we can say that the value is constant, right? So this is what we call as speed time this is going to be distance time graph, right? This is actually distance time graph, right? So the gradient of the distance time graph actually refers to the speed at which the vehicle is going. If the gradient for given points is not changing, if you take several points and compare the values, if the gradient is not changing, then we call this as constant speed, right? Okay, now this is for a constant speed. At times you get a graph something like this. I'm just going to put a graph again, right? But let's draw some values for y and x, right? And for y we are plotting d, and for x we are plotting the time t in seconds, right? Let's say if the car was at 10, then it went to 20, let's say it went to 40, and then finally to 80, right? Now as you can see, there is not a gradual change in distance, right? While at the time, let's say it's 2, 4, 6, and 8, right? So let's try and plot this, how the graph is going to look like. Again, we point this, let's go with brackets of 10, 20, we got 30, we got 40, 50, 60, 70, and then 80, right? Okay, and now let's plot time as intervals of 1, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9, right, as an extra. So over here time is in seconds, distance is in meters. Okay, now let's plot these values. I'm going to change the color to a little darker blue, right, over there, to change it, to differentiate between this graph and this. Mind it, this over here is a bit different of a topic we're discussing. This is just an average idea of what speed is supposed to be between 2 points, but now we're actually plotting values, right, from these charts. So in the first we have in the 2 second the car was at 10. Let's mark a point here. For 4 seconds the car was at 20, so let's get that over here. Now at 6 seconds the car was at 40, right? As you can see, now there's a bit of a change in the trend at which the points are going, right? And at 8 seconds we were at 80. So when I try and draw a line, it is not a line anymore, it is actually a curve. As you can see, the gradient is now changing, right? The line is changing its path, or what we call as a curve, right? So this is a curve. This over here was a line, right? A line is a straight line segment, right? It's a line segment, it's straight, while curves are not supposed to be straight. So whenever you get a curve, that means the gradient is changing. So let's chart the gradient, g1, right? Let's take it between these two values, right? G1, and we'll take G2 over here, right? So G1 is actually delta y over delta x, right? That refers to 80 minus 40 divided by 8 minus 6. That is going to be 40 divided by 2, resulting in 20, right? So G1 is 20 meter per second. Okay, now let's calculate G2. G2 is going to be again delta y over delta x. That is going to be 20 minus 10 divided by 4 minus 2. As you can see now, it is going to be 10 divided by 2, which refers to 5 meter per second, right? Okay, let's also take another G3 over here, right? So G3 is going to be again delta y by delta x, and that is going to be 40 minus 20 divided by 6 minus 2. So this is going to be 20 minus 2, and that is going to be 10 meter per second, right? Now as you can see, all three values are actually different, right? And if I take the difference between these two, between 6 and 4, and between 8 and 4, if I take larger intervals, even then I'm going to get different values, and that shows that the gradient or the line is changing dramatically, right? So for lesser time, initially the car was covering lesser of a distance. Let me just plot these values like this for you, right, to depict that the interval of time is actually pretty much consistent, while the interval between the velocity is actually not consistent, right? As you can see, the time intervals, this interval, the gap between time is pretty much the same, while the gap between the speeds, the distance is changing dramatically, right? So this is what we call as variable speed, right? That means the speed is changing over time. So let's now define speed, right? Now we're going to define what speed is, right? So first let's define constant speed. So what is constant speed? When an object covers equal intervals of distance in equal intervals of time. That is when we call it constant speed, right? This we can see from this graph that for, as you can see, the distance between these is same, while the distance between these gaps is also pretty much same. Now I've drawn a little rough diagram, so they may not be appearing as equal as they're supposed to be, but let's consider that these, as you can see, the values are telling you that there are 8 equal intervals. So a constant speed is actually when an object covers equal intervals of distance in equal intervals of time. That is what constant speed is. And now let's define variable speed, right? So when an object covers equal intervals of distance, sorry, let me just, not equal, unequal, I should say, right? Unequal intervals of distance in equal intervals of time. Now there is a big change over here, right? This word unequal, and for the other one, this is equal intervals. Now remember, the intervals of time, I'm just going to use the rainbow pencil to just highlight this, that the time is actually taken equally in both cases. Why? Because if you change time intervals for each of these, then we won't be able to evaluate what was happening to the graph, right? So time has to be equal, which over here in these values you can say that the time was at equal intervals. It was 2, 4, 6 and 8. That means the interval, as you can see over here, and over here, was the same, right? The difference of time was same, while the difference of speeds was actually different, right? For each of these gradients. While in case of this, as you can see, the time interval was also same, right? That was 8 for both, but the intervals of distance were also same, right? So that is why we called it constant speed, and this as variable speed, right? Now let's talk about velocity, right? So what is velocity? Velocity is actually defined as same, and I'm going to defined as same, but we use the term displacement instead of distance, right? So that's the only difference we're going to have, right? Over here, if we defined constant speed as this, then we are going to use the word distance. Instead we will be using displacement now, right? And similarly, when we define variable velocity, we'll take the same definition of variable speed where we had distance. Now we'll use the word displacement over here, right? So that's the only difference between this, and let's define this, right? We can actually draw the same graphs for both of them, speed and velocity. They can have the same graphs as long as the direction of the object is not changing, right? If the direction changes, then obviously displacement will be changing compared to the distance. So for an object, let's say from point A to point B and then point C, right? So an object moved from point A to point B. Now as I'm drawing arrows, to represent that the direction was changing. And then I drew this graph, right? This one, right? So over here, uh, we call this was, let's say, 100 meters, and this was 50 meters, while this between point A, I'm highlighting, and C is actually 110 meters, right? Let's say, I mean, it may not look the same, but let's just consider that this is the value that we get between point A and C. So this is the shortest path between A to C. An object wanted to move from A to C. So for using the road, it had to go through point B and then went to C. But let's say if we were airborne and we were able to fly, then we can actually go from point A to C directly, and that is what this displacement is going to be. So for over here, speed will be calculated. Let's say if for this time taken was 10 seconds, for this it was 8 seconds, and then it was 4 seconds, right? So we will calculate two speeds, speed 1 and speed 2, right? 1 for this one between A and B, and then for B to C, right? This is A to B, and this was B to C, right? So speed is going to be distance over time. It is going to be 100 divided by 8, and this is going to be 50 divided by 4, right? So if we calculate this, let me just grab my calculator. So 100 divided by 8 is going to be 12.5. Let me just write this, 12.5, and then over here it is going to be 50 divided by 4, that is also 12.5. So since the velocity since the speed did not change, so we can say that the average speed is again 12.5, right, meter per second. Okay, per second. Okay, at the edge I think it's a bit difficult to write. Okay, now let's calculate the velocity. Now velocity is also going to be similar, but instead we will use displacement over time. Now the formula changes, we use the word displacement. So displacement over time, that is going to be 1110 divided by 10 seconds. Now this is meters, so it is going to be 1110 divided by 10 seconds. So that is going to be 11 meters per second, right? So the values for velocity and speed may differ for certain cases if the object is not going in a straight line, and in this case the actual path that was taken was actually for the car was through this, right? It went like this. So in our calculation it is actually in terms of the shortest possible path. The average velocity is 11 meter per second, while the speed is actually a bit higher than that, right? So keep this in mind, that the velocity and speed may have different values, especially when directional changes are incorporated. When direction changes, speed may not be equal to velocity, right? Because we're not incorporating velocity for each of these intervals. Instead, we are calculating velocity from A to C directly, and we're not considering point B over here for our calculations, right? That is the net velocity, right? So this is a bit of understanding what speed and velocity is. Now there are several ways in which we can discuss this. I will definitely discuss this more deeply when we're discussing about the graphs. So let's get into speed time graphs now entirely. So first, distance time graph. So what is distance time graph? We are going to discuss again. Let's say if we have graph, right? Now I'm just going to discuss the nature, so I'm not going to mark any values. The time is in seconds, the distance in this. So I'm just going to draw several lines. I'm starting from point O, which is at 0. So again I'm going to draw a straight line like this, right? Then I'm going to take a line like this, and then I'm going to take another line, which I'm going to draw something like, let's say, this, right? Let's take this, and then I'm going to draw another line which is going to be a bit curved, let's say like this, right? So let's classify each of these. So let's call this A, let's call this B, let's call this C, and let's call this D, right? So let's identify what A is. A is actually constant speed. Why? Because the line of the distance time graph, let's define line of d by t graph shows speed, right? Okay, so line A is a constant speed, line B over here, as you can see, the time is counting, but let's say the d distance is not changing, and when the distance is not changing, that means the car is parked somewhere. It is parked perhaps a certain distance from you, but it's not moving, right? The time is moving on, as the clock wouldn't stop, so we can say this is at rest, right? So that means it is not moving at all. When the distance is not changing, we call an object at rest, right? Then line C, the car may be parked maybe farther away from you, but it moved at a constant speed. That is also constant speed. Why? Because a line is a straight line. So whenever you get a straight line away from both the axes, from both the x and the y axis, we call it constant speed, right? Then we have line D, which is a bit odd, right? It is curving, so we called it variable speed, right? So this is a bit of identification of what these lines are supposed to be. Now over here, I always discuss a unique case. Let's say I have a line which is drawn like this, right? What about this point line X, right? What does this line X represent? Can anyone suggest what this line X could be, right? If just take a moment and try and figure what this line X could be. You know, it's a bit odd, but if you have figured it out, then it's fine. You can put it in the comments. If not, then I can give you the answer just in a moment. Let's wait a few more seconds for you to think before we can answer this. If your answer is constant speed, then my dear, you're wrong. If you think the object is at rest, again you're wrong. If you think it's variable, and by the way, I tried to draw a straight line, but as I said, these graphic pads are too frictionless for me to write properly. I'm more in tune with a paper and a pen, so this may not appear a bit straight, but I drew a straight line over here for x, right? It's a straight line. So it's neither variable speed, it's not constant speed, it's not rest. Then what could it be, right? If you haven't figured it out, so it's what I call as impossible. And why I'm going to call this an impossible case? Because if you remember, we discussed that distance is actually length, right? And length is a base quantity, right? Base quantity. And no base quantity can be negative. Base quantities can't be negative, right? Let's just say I try and ask for your height. Would you say I am minus 6 feet in height? No, not possible, right? So base quantities are always positive values, right? They go ahead of 0. They don't go into the negative side, right? They don't go to the negative. That's why it's not positive. It's not possible. So this is an impossible case, right? So this X line probably you will never see in the exam. Just as a sake of poking your head, just food for thought, I drew this line because, as you can see over here, let's say this was 100 meters. So how is it possible that the car could reduce its distance? Now we can say that the car backed up or something, but over here the gradient is going to be negative, and we cannot have negative values for distance, so mathematically this is not possible. Even though we may consider the case that the car just reversed, it was in reverse gear and it was moving, even then we have to understand that it was moving from that certain point to a certain distance, so we take the distance for that car from that specific location. So this is supposed to be point A and point B, right? We cannot say that this is point A and then this is point B, right? This is not possible. So this is kind of an impossible case if you consider that length cannot be negative, right? So that's a bit of an understanding or identification of the graph. Now let's make more of a complex graph, right? Okay, let's draw another distance time graph. Okay, this is d by t, and this is t or in seconds. Sorry, this is not d by t, it's d over meters. In meters, in graph, always draw, define the units and the base of this. Okay, let's say we have a bike, right? Now you're supposed to identify something. I'm now going to draw something. A bike started, then it did something like this, another like this, and like this, and then it went straight like this. Over here, from this to this point, I'm just going to mark these points now, right? You are going to identify what was happening. So this is point O, origin, this is A, this is B, this is C, this is D, and this is E, right? So let's mark them up. First of all, I want you to identify at what points did the motorbike change its gears, right? So you do know whenever a gear is changed, you have to re-accelerate that gear for the vehicle. So if you guessed it, then yes, gear change would be at A, B, and C. Why? Because this was the initial gear, the first gear. So the first gear accelerated, then it completed its revolution. At point A, it changed its gear. It was second gear, then it worked up to the third, and now the fourth. And from fourth, it increased its speed a little bit, then it went constant. So here we have constant. This is also variable. That's also variable. That's also variable, and this is also variable, right? So this way you can identify different parts of this graph, what really happened to the motion. So as I said, this unit is all about describing the motion of an object, and the best way to do is using the graphs. You can simply if you get a graph, you can simply discuss the motion of the object, and then through that changes you can also describe other effects that were here happening to the vehicle. In this case, if the question was asking when did bike change gears, right? So that's when it did. So you can easily identify the sequence of the pattern. It's point A, B, and C. They appear to have the same changes. So that's when the bike changed gear. But from C to D, we don't see a similar change in the pattern. So we will say that over here it did increase its speed, but it didn't change the gear, right? It went into a constant speed. That means the gear was at its maximum ratio, and it was not increasing its speed furthermore, right? So this is another way of discussing describing the motion of an object using these graphs, right? So I think that's bit of an understanding of what these graphs are supposed to be like. Moving on to the next topic, now acceleration, right? So what is acceleration? Now we did discuss variable speed, right? So what is variable speed? Variable speed is changes in speed, right? When an object is not covering equal distances in equal intervals of time. So that's when we call it uh, the object is having variable speed. So variable speed must be due to some acceleration. That means something did help it increase its speed or reduce its speed. So acceleration I'm going to define as change in speed, or we can say uh, uh, you know uh, change in speed over time. I would rather call this velocity, because again, direction would matter in this case. We will understand in a moment why. So we can say that acceleration is delta v over delta t, right? So again, it could be constant acceleration or variable acceleration. We will come to that in a moment. So let's just say between instead of just doing an object, let's draw a graph, right? If you remember, we had this graph in which we had uh, you can say 10, 20, 30, 40, 50, 60, 70, and let's draw it here as well, right? 80. And for time we had actually 2, 4, 6, 8, right? So when we drew the graph for this, we said at 2 seconds it was at this, at 4 it was at 20, and at 6 it was at 40, and at 8 it was at 80, right? So when we drew the graph, it went something like this. It was a bit curved, right? Sorry, it went a little out. Let's make the point a little bigger. Okay. Now this is the case. As we can see, there are not equal intervals of time and distance. I'm just going to draw this. It's a bit rough, but imagine that the time is in equal intervals. I will just chart it out. So as you can see, the distance is changing consistently. Now let's not consider this as distance. Let's call it speed. Let's say it was a speed in meters per second, and this is also now time in seconds, right? It's a similar graph, except over here we are discussing now the speed and not the distance. So if a car was going at 10 meter per second initially, then it was at 20 in the next 2 seconds, and then the next two it was at 40. The speedometer read 40, and then the speedometer read 80 in the next 8 seconds. So if we chart it out, let's say we chart y and x, that is v and t. So let me just chart this. So the values were something like this. It was 10 over, okay, let's just we start from 0 this time, right? We always forget the 0, the origin. So it is going to be 0 over 0, right? It is going to be 10 over 2. It's going to be 20 over 4. It's going to be 40 over 6, and then 80 over 8, right? So let's find a. So I'm just going to draw another one, right, which is the gradient. I'm just going to draw this. So sorry, yeah, a should be here. So this, let's draw a for these values, and a is actually the top value, the difference of these two divided by this. So it is going to be the difference of these two, right? So for 2 and this, the acceleration is going to be between 10 minus 0 divided by 2 minus 0. It is going to be 5, right? And then for 10 minus 20 minus 10 and 4 minus 2, it is going to be again 5, right? Now the next one, as we're supposed to be taking differences, so we need to take 2 points, right? So the higher point and the lower point, it is going to be 40 minus 20 divided by 6 minus 2. It is now going to be 10. And for the next point, this is going to be actually 80 by this, right? This is going to be 40 divided by 2. That is going to be now 20. So for units, as we know, this is velocity. Velocity is actually meter per second divided by seconds again for time. So the units are meter per second square. This will go up and add up to the negative value of the second. So it is going to be in meter per second, right? So these are the values for acceleration, right? So from here we can say that the acceleration is actually changing, right? So this we can refer to as variable acceleration, right? Contrary to this, if we're supposed to draw linear acceleration, or you can say constant acceleration, it is supposed to be a straight line, and we do know constant means a constant gradient. So if it were v in meter per second, right, and time in seconds, then we can say that this over here is going to be a straight line. This represents constant acceleration, and that I can chart simply as this y over x, where y is going to be now the v and t, and let's say it is 0, 10, 20, 30 and 40, right? And we simply just put a difference of 1 centimeter for the sake of understanding. So 1 second, every second we are measuring the speed. So if we chart out the acceleration, then the acceleration is going to be, for these two it is going to be 10, for this also 10, and for this 10, and this also 10, right? The differences would be there. Now since the acceleration is not changing, we call this as constant acceleration, right? And this we see from the straight line graph. So if you draw this as 10, 20, 30 and 40, and for the time 1, 1, 1 and 1, so we now get to have this chart something like this, right? So again, please don't mind, it may not appear to be the straight lines or accurate lines. So again, if we define constant acceleration and variable acceleration, so we can say constant acceleration is going to be when an object has has equal intervals of speed, velocity, I'll write both, right? It works both ways, in equal intervals of time. It's similar to speed, except in speed we had distance, now we're talking about velocity. And variable acceleration, right? So what is going to be variable acceleration? Similarly, it's going to be the same when an object does not have equal intervals of speed, again velocity, and we'll understand why I'm using the word velocity over here, in equal intervals of time, right? So there it is, that when we do this, these are two different, and over here we can see from the graph that's a straight line, it's a curved line. Then there are different types of speed time graphs. We will discuss that in a moment. So I hope you understand what acceleration is. Now this is just the basic understanding of what acceleration is. We'll have a much better understanding of acceleration once we go through the complete context of acceleration, right? Especially when we will discuss the speed time graphs. Now we'll go directly to speed time graphs and try and explain this as quickly as possible. So let's just say I'm going to have several values, right, for y and x. Over here we're going to have which is speed over time, right? So let's just say if it was 0, it's 10, it's 20 and 30 and 40. I'm just going to draw a few points, right? And the time I will take 1 second for all of these graphs, right? 1, 2, 3, 4, 5. By the way, in the previous one I just did this tiny little mistake. I only took the intervals, I didn't actually elapse the time. So let me just correct this over here as well. This is going to be actually sorry, scribbling. Yeah, since we were supposed to be taking differences, so let me just put it 2, 3, 4 and 5, right? So oh sorry, again it should be from 0. At 0 we cannot have time. Okay, right, okay, that's going to be 0, 1, 2, 3 and 4. Yeah, that's when we're going to get tens, right? Okay, now for speed time graph, let me just make that embedded over here as well. We can actually take 0 or 1 as well, it doesn't matter, but let's just, for the sake of ease, let me put a 0 over here so that you don't get confused. So 0, at time 0 we are not we're not starting a stopwatch. 1, 2, 3 and 4. So if we measure the acceleration for each of these points, it is going to be the combination of these two values. This is going to be 10. Again, it is going to be 10, 10 and then, right, 10. So this is acceleration, and this is in meter per second square, meter per second square, right? So this is in meter per second, and this is in seconds, right? These are the units, right? Okay, don't confuse the units with values. So if I draw this, it is going to be actually v in meter per second, right? And time being in second, it is going to be a straight line, as we just discussed, right? Now in terms of variable speed, there are several cases that I need to discuss, so I'm just going to chart it out, and this is the most important factor while discussing acceleration. So let's just say if we have speed from 0, it goes to 5, it goes to 15, it goes to let's say 30, and it goes to 50, and the time I'm still going to take as 0, 1, 2, 3 and 4. And again, this is for the sake of ease. Now if I just take the difference between these 2 points, right, I'm going to write the formula just once for understanding, and then I'm going to draw all these. So acceleration is actually v2 minus v1, or I would rather, unlike the IGCSE book, I like to actually write it as the initial and the final value. For here I'm going to use final minus initial divided by the difference in time for the final point minus the time for the initial point, as it is delta v by delta t, change in velocity or speed divided by change in time, right? So the acceleration is going to be this time around a bit different. This is going to be 5. Now this is actually 5 minus 15 minus this is going to be 10, and 10 divided by 1 is going to be 10. Now again, the interval is 1 second, right? It is 1 second for time, but over here, as you can see, the gap over here is 5, this difference is 10, this difference is actually 15, and the difference is over here is actually 20, right? 50 minus 30. So by dividing each by 1 is going to be 15 and then 20. Now as you can see, the speed is increasing and the acceleration is also changing. So this is variable acceleration, right? As the speed is increasing, but just look at the values now, right? This is variable acceleration, but this is increasing acceleration. Why? Because the value for acceleration is also increasing from 5 to 10, then 10 to 15, and 15 to 20, right? This is called increasing acceleration, right? Okay, now let me draw another chart. As I said, these charts are going to be more important than the graph for now. I will draw these all out on the graph and then refer these values over there for your sake of understanding. But for now, let's say we started from 0 we jumped up to we went to 10, then we went to 18, and 24, and then finally to 28, right? Now if you see the difference, it is 10, it is 8, it is 6, and this is now 4. Now the speed is increasing, right? Speed is increasing. So this doesn't mean that you're braking, your speed is increasing. Why? Because the value for speed is consistently changing, and it is having an uptrend, right? And let's for time 1, 2, 3, 4. As I said, for your sake of understanding, I'll keep the interval of time interval is 1 second, right? So we just need to divide for this formula this this value by 1 second as per this formula, right? So just for the sake of understanding of calculations, we are just going to get this. So accelerations are going to be for this is going to be 10. I'm just going to keep the distance visible, right? Over here it is going to be 8, over here it is going to be 6, over here it is going to be 4. Now now you see a clear difference between these patterns of acceleration, right? So each one of these cases, I'm going to just separate this with this rainbow pencil, so that you don't confuse them, right? Okay, now let me just put a line over here, right? And now you can see the difference, right, between this acceleration and this acceleration, right? This I'm going to refer to as, this is also variable acceleration, but the trend is kind of opposite. And remember, the speed is still increasing, right? In this case, speed is again increasing while the acceleration was also increasing, right? The values for acceleration were going up, right? In this now third case, we see that there is a downward trend between these values. So we will say this is decreasing acceleration, right? So keep this difference in your mind. When the values of acceleration are increasing, we call it increasing acceleration. Remember, in both cases, the car is speeding up. As you can see, it started from 0, it gained a speed of 28. In this case, it gained a speed of from 0 to 50. But the trend for acceleration was upward, while in this case, in the third case, the trend for acceleration is downward, right? I will chart this out on a graph in a moment. Now we're going to discuss something different from this, right? At times, the car is already moving and it applies brakes, right? So let's look into something known as deceleration. Okay, let me just make it more neat so that if you review it later on. Okay, deceleration, also known as braking, also known as retardation, right? So remember these three names, these are the same. The third name is also there. We also call this as negative acceleration, and we'll understand why we call this as negative acceleration, right? So negative acceleration, when we use negative sign with value, and when we do not use the negative sign, we have to call this as deceleration. We don't need a negative sign for the word deceleration. When the question asks what is the deceleration, do not use the negative sign, you don't need to. But when the question says negative acceleration or just the acceleration, then you do have to put negative sign if the negative sign appears in your calculation, right? So I will go with negative acceleration for the moment. So let's go with y and x, right? So over here we have velocity, over here we have time. Let's say we stopped, our car was going at 50, it came to 40, 30, 20, 10, and 0. So it is going to be 0, time at 0, the car was coming at 50 when we started stopwatch. 1, 2, 3, 4, and 5. Again, the difference is 10, 10, 10, and 10. And once we divide it by 1 second for each of these intervals, it is acceleration is going to be actually 10, 10, 10, 10, and then 10, right? So we will call this as constant deceleration, and this is also represented as a straight line, but instead now if we were at a value of 50, let's say 50, 40, 30, 20, 10, and now 0 for time intervals, the graph is going to appear something like this, right? It's a downward trend, right? So this is the opposite. So this is again, this is the V in meter per second and T in seconds, right? So this is a downward trend compared to our original you can say constant acceleration, which goes up. That is constant acceleration. Let me just write this over here, right? This is constant acceleration or positive acceleration, and this now over here is constant deceleration or constant negative acceleration, right? And why negative? Because if you see, if I take this, a is equal to Vf minus Vi by change in time, right, by t, which is 1 second. So it is going to be 40, which is the final one, minus 50 divided by 1, and that is going to be minus 10 by 1. So I'm just going to introduce this minus 1 sign. That is the very reason we call it negative acceleration. Now remember, if I ask you what is the deceleration value, now when I use the word deceleration, then you simply write 10 meter per second, right? And what if I say what is the acceleration, then I need to incorporate the negative sign over here, right? So for deceleration, no need to use negative sign, right? You don't need to, because deceleration already refers to the minus value, so you just need to write the numerical value, so no need to use a negative sign. When if I just ask for acceleration and your values are trending in a way that they appear to be negative in nature, then you have to use the negative sign. Now in most of the cases in the exam, it is actually the deceleration that is being asked, so you wouldn't have to use a negative sign, but at times they do. In some of these questions we do come across this value, so for this we will say show negative sign to impart the idea that this is deceleration, because the word acceleration was used, so we have to classify that this is negative acceleration, which refers to deceleration, right? Okay, this minus refers to deceleration, so you have to classify what kind of acceleration you were talking about. Now just like positive acceleration, we had a variable increasing trend and decreasing trend. The similar way we also have trends in deceleration. So let's say if we have values of y and x, right, and then we discuss this as v and t. It was 50, 40, 25, and then we have 5, right? So let's just talk about this much trend, right? So it is 0, 1, 2, and 3, right? So the trend, if you look at this for acceleration, the difference is 10, the difference is 15, and the difference is 20, right? and this is in minus, so that's the minus sign over here, right? Why? Because the higher value is smaller and the lower value is bigger number, so the values are going, the difference is going to be negative. That is why we call it negative acceleration, right? So if we talk about acceleration, so then this is going to be minus 10, minus 15, and minus 20. Now even though the car is braking, speed is decreasing, right? Why? Because as you can see the trend, right, the speed is decreasing dramatically, but negative acceleration has increasing trend, right? So we call this as increasing deceleration, right? And for another case, let's draw a counter case for this, right? Let's take more values for x and y, right? And I'm just going to keep this acceleration visible to you. So y and x. Now I'm not drawing the graphs. As I said, I will draw the graph at the end just once to depict all these lines, to give you these trends, and then you can simply compare these values on your own to have a better understanding. If I just give you everything as a piece of cake, then obviously you won't be putting your mind to understanding this. So let's just say if we had 50, it jumped to 40, then it jumped to 32, then it jumped from 32 to let's just say 26, and then to 22. So let's draw the difference, minus 10, minus 8, okay, let me just recorrect this, 26, yeah, I think that's fine. Okay, that's minus 6, it is going to be minus 4, right? Again 0, 1, 2, 3, and 4. So if I draw the differences, let's draw the acceleration for this. It is going to be minus 10, minus 8, minus 6, and minus 4. Now as you can see, over here the acceleration had increasing trend, and over here along the way, while speed is decreasing, but acceleration, or let's call it deceleration for this case, because I'm not going to say negative acceleration, deceleration has a decreasing trend, right? So this is what we call as decreasing deceleration, right? So I will draw a quick chart of what these lines are supposed to be, right? And I'm going to confuse you so that you put this in your head and try to think more vividly what is actually happening in the speed time graph when such a graph is going to appear, to clarify the maximum difficulty level, right? So I'm going to draw this line, right? Then I'm going to take this line, right? Then I'm going to draw a very odd line like this, right? Okay, which I haven't discussed though, but you will probably be able to understand. This is a straight line, right? Then I'm going to draw let's say an upward trend like this. Okay, let me just separate these two. Okay, let's discuss these three cases. A, this is B, and this is C. So A is constant acceleration, B is constant deceleration. Why? Because it's a negative trend, right? And C is constant speed, and or known as zero acceleration. Why? Because the value for velocity is not changing over here, right? It's a straight line. And when the velocity is not changing, then definitely there is no acceleration, and we defined acceleration as a change in speed. When there is no change in speed, then obviously acceleration is zero, right? So that's one part. Now let's go for the variable ones, right? I'm going to draw now two more lines over here with curves. So let's take the blue one. Let's say it was like this, and then we have something like you can say something like let's draw this from 0 like this, right? So this is B and this is A, right? So what is A and what is B, right? Think for a second. As you can see, these are variable, both of them are variable, but you need to understand what is happening to the time interval. Let's say if we break the time in equal parts, I'm just going to you know, break it in equal parts of time, and I'm going to take this pencil and I'm going to try and mark these points to break them in equal intervals of time. As you can see, for line A, for each interval of time, equal intervals of time, the obviously the value for speed or velocity is changing, right? But over here the trend is up, more up, and more up, right? And definitely much higher. For the other one, it is actually already up, less up, lesser up, and it is pretty much getting straight, right? So definitely for line A, this is increasing acceleration, and line B is decreasing acceleration, right? And why is that so? Because for as these arrows depict the gradient, as the gradient is reducing over time, so it's decreasing trend. And for line A, over time the gradient is actually getting more steeper, so it is an increasing trend. So keep the gradient in mind. So just break it down into these time intervals and see what is happening to the gradient, right? Just you can simply draw these you know, small rough vectors, right? And see what is you know, approximate direction of the line, and then you can identify whether the trend is increasing or decreasing. So this will help you understand what increasing acceleration and decreasing acceleration trend is going to look like. Now the last graph that I'm going to draw for the day is actually for the deceleration now, and that is going to be again meter per second and time in seconds. Now I'm again going to draw two lines. One is going to be like this, and the other is going to be somewhat like this, right? Let's call it B, and let's call it A. And similarly, I'm going to break it down in smaller fragments of time, equal intervals of time, and then I'm going to review what is happening to these lines, right? I'll try to keep straight vertical lines so that, oh, I just said straight and it went all the way quickly. Okay. All right. Okay. Now look at this. This is the arrow, steeper, more steeper, and pretty much vertical, right? That's the trend for line A, and for line B, it is actually this, and becoming more horizontal and pretty much horizontal. So just by drawing these lines, I'm pretty sure you have guessed it what A and B is. Although these are negative values, so these are deceleration. So A is going to be, as you can see, the gradient is increasing, it's becoming more steeper. That means it's becoming more vertical. When these arrows tend towards the y-axis, or you know, and they're pointing downwards, so it is going to be deceleration. So I will call this increasing deceleration, and point B as decreasing deceleration, right? So this is the most important thing that you need to understand between different understandings of what acceleration is supposed to be, and how these different values for accelerations are going to affect. I hope I made these things clear. If you have any queries or any confusion, just post your questions in the comments, and try to respond as soon as possible. Thank you.